Welcome to Green Disruptors, Scaling the Future. I'm your host, Megan Kjar, and today we're diving into one of the most persistent environmental challenges of our time, waste. My guest is Marc Bacon, the Chief Operating Officer of Omni, a company that's figured out how to turn our most unwanted garbage into clean, usable energy. From overcoming billion-dollar industry failures to designing a scalable system that captures more value from waste than ever before, Marc's story is both inspiring and eye-opening. Let's get into it. Welcome back to Green Disruptors. We're going to have another impactful conversation today, and my guest is Marc Bacon. He's the COO of Omni. And hi, how's it going, Marc?
All well, thank you, Megan. Sorry about the noise.
Here. Oh, we're good. We were joking a little bit before we started because you've got a cool green screen going on and it's giving you a green halo effect, which I think is appropriate for this podcast. So listeners can't see it, but I think it looks great.
Thank you.
All right, so why don't we just get started by tell us about Omni, first of all. What does the company do? How long has it been around?
Sure. So the company started under a different name, same company. It was called Plasco Conversion Technologies. Started in 2005. I joined in 2007. And what we do is take the waste that nobody wants, the garbage that comes out of your kitchen or out of a automotive shredder residue, or basically the things that ends up in landfill or incineration. And we designed a technology and spent a lot of money to get there that will completely convert that garbage, that waste, to energy in the form of a syngas, can be converted to power, clean fuels, and whatnot. Water and a non-leachable slag with 100% diversion from landfill. So that's our business, is to really create value from what people normally throw away or burn.
Okay, so what has been, it's such a great idea. I think people have been wanting to do this for a long time. What have been some of the biggest challenges to get this to be something that works and that's cost effective?
Sure. Excuse me for the noise in the back. I get emails coming in. There's a number of them. Part of it is that waste is so different. A banana peel is very different from an orange, is very different from a rope, is very different from a baby's diaper. And all that coming together, and you're trying to make some consistent product out of it, is very difficult. So there have been a lot of people have tried, since the time of the caveman, man said there's really only two solutions for waste. I either burn it or I bury it. And in recent years, people have tried to gasify it, but what they do is take a gasifier that was built for coal or built for biomass or something that is really consistent and tried to adapt it to waste, and every single one of them has failed because of the fact that it's not homogeneous. So on the technical side, that's very difficult. I could get into a lot more technical parts of that, but just the fact that it is extremely varied, and what most people do is to spend a whole lot of money trying to sort the waste to get what they want, put the rest of it back in landfill, and then chop that waste up into very, very fine particles, and then dry it and make it into something that looks like confetti, and then try to process that waste. And the amount of effort to do that is well over $100 a ton. And so it makes it not commercially viable. So that's the technical side. And then on the commercial side, a lot of it is people have run out of money, and so they've scaled up and immediately gone to making a first commercial project. And those projects have inevitably failed. There's been scale-ups. In one instance in 2016, a scale-up of 64 times it failed and cost the company $1.1 billion. Recently, there was another one scaled up 125 times and cost over $800 million. There's just a lot of steps skipped because it's so expensive to get from a concept to a final solution. And in those scale-ups, there are a lot of pitfalls. So I guess those are really the two things. Yeah.
Yeah. So how is Omni still alive, and how have you solved these problems?
So how we're still alive is probably because God's been good to us. It's been good for everybody, but us in a good state. We had a serial entrepreneur who was a CEO at the start. Excuse me. Had good contacts. We raised private equity money, spent $407 million US dollars of money. About 1.2 million person hours. So I wouldn't say that we were geniuses. We had a really good team. I worked really hard trying to have people who got on the bus and did the right things and kept the wrong people off the bus, sort of in the Jim Collins good to great philosophy. And we worked long hours at it. And you ask what is the difference? Probably because we raised enough money to just keep going. I remember 4 different times I was in the CEO's office and says, you have to relax the criteria of needing to take curbside waste. And he said, well, that's what's special about us. I'll keep raising the money. You make it happen. And so it was that persistence of just working away at things. And we started with the notion that we were not going to adapt equipment that had worked in other things to meet the waste. We were going to start with the waste and make it go to the end product. So we had a very differentiated product where the first stage was really a gasifier whose job was to dry the waste and convert it to a charcoal, because a charcoal really consists of only the ash fraction and the fixed carbon, all the volatiles which have a lot of variety to them. The water and the volatiles have been driven off. So the first stage was that, and we did that in a grate-based vessel that looks somewhat like an incinerator, except it's substoichiometric, which means it's not burning, it's just gasifying. And we did the gasifying using reheated, recovered heat. And then from that charcoal, we put it in a second vessel, which was vertical updraft gasifier, and we extracted the energy from the fixed carbon. So we end up with less than 1% of carbon not used, which is, as far as I know, better than any other gasifier in the fluidized bed and so on. And in the process, we also melted the ash fraction, which would be, if you were to put that in a burn barrel and burn it, it would be what you'd find in the bottom of your burn barrel. We melted that, granulated it, and turned it to a vitrified slag, which traps all the heavy metals. And that's one of the big things with municipal and other wastes, is you don't really know what's in it. So by trapping the heavy metals and not allowing them to get into a leachable state, we then end up with a product that looks like gravel that is as innocuous as a Coke bottle, in the sense that it won't leach into the environment. So we end up with really a black hole for waste that grabs up the waste. And then we do a lot of work on the energy side to make that conversion very efficient so that you can make money from selling the end product.
Wow. So you mentioned before that the old ways of doing it are, $100 per ton or something like that. Like, is there a cost comparison now you have to factor in selling the energy, I'm sure, but. Sure.
So the difference is we do a number of things. By recovering the heat, let me step back. I write better than I speak, but I'll try again. I step back in the feed preparation. We shred to 4-inch minus. We take out the bicycles and the bed springs, the things that don't have value, and you just sell them back as scrap metal. But we're not out to get the final pieces of metal because they bother the project. So we will pull out propane bottles so we don't have explosions, but the equipment's designed so it would accept them. And the rest of it that is a fuel, it could have metal mixed in with it. We don't really care. So we shred to 4-inch minus, which is a really rough shred. And we pull out, with one magnet, we pull out the large pieces of metal, but we don't spend time getting to 1-inch minus and taking all the gravel and the broken china and somebody's broken sink parts and things like that out of it. We process all of that, which saves, like I said, about $100 a ton. Then in the actual processing, we extract, if I compare to a fluidized bed that doesn't get rid of the char, we extract somewhere between 15 and 18% more overall efficiency just by getting rid of all the carbon, which also adds value at the end in the amount of product you make and the energy throughout. So those two combine, you get paid to take waste. Biomass gasifiers have to pay to get biomass, and it's very hard to get big quantities of biomass. We will get paid to take waste because it's a problem. It'll either go to an incinerator or a landfill, so we get paid to take it. And then we get paid on the back end for our product. And because we'll make our 17% more product than other people, it makes a good business out of it.
Wow, that's amazing. So I'm sure there's a lot of speculation towards this technology because it sounds like the solutions that you've come up with are fairly new. So what would you have people understand that they might be getting wrong right now about how it works?
So there's all sorts of understanding. The deep understanding, and I won't mention names, but because public broadcast, but the petrochemical companies who do their deep due diligence and the large engineering firms that do deep due diligence don't have a problem understanding. The environmental ministry, we've done in Ontario, we ran a demonstration plant for a decade here and gathered 200 gigabytes worth of data. So we have the environmental data. What is hard for the general public to understand is it's not incineration. Incineration is burning. This is less than burning, otherwise you'd have no fuel value, so it's substoichiometric. So the people who are saying, NIMBY, not in my backyard, we had a little bit of that here in Ottawa when we did our demonstration plant. We got a citizens committee, if you want, to be added into our permit to operate as a demonstration plant that had a local councillor, university professor, two people who were environmental activists and so on, and they had full access to all the data and were the designated whistleblowers to tell the Ministry of Environment if we were misleading or if we had the wrong things going. Mm-hmm. And that really worked to be very, very, very transparent and say, here we are. So, you ask what there is a concern in the public. When the public looks at this and they compare it to other things, it's fine. The other concern is in the mind of investors, people who are investing capital, typically are happy with risk, but they like debt to accompany them because they can get better leverage for the capital. And debt is very, very allergic to risk. So debt doesn't mind being third of a kind. They don't want to be first of a kind or second of a kind. So we've had to work through that. And we have gotten, and again, I won't name names, but we have 3 large insurance companies who have done their due diligence and who are willing to wrap the process guarantee to make it easier for the debt to come on board.
Okay. So I'm going to lighten it up for just a minute. Can you tell us how you got into this industry personally?
Sure. Strange how things happen. I went to school in Texas, grew up in Africa, went to school in Texas, came to Canada working in industry back when there was industry. I was in industry and heavy machinery, engineering, and got into senior management. Pure happenstance. I was helping a company out that got a license from a large utility for a new technology they had that was going to use plasma. And they wanted some help in this, so I helped them out and spent some time doing this and got to be known as being not bad with plasma. And plasma was not the center of Omni's technology, but it was one of the elements in it. And when they got their plant built in 2006, it didn't work. Had a lot of issues with it. They went looking for somebody to help troubleshoot, and my name came up. And one thing led to another, and I took on the task of leading a team. So it was by happenstance I got into it, and I've had really good people working with me, and I don't know anything else to say except, we've worked really hard, and the people that I work with are exemplary. So that's...
You mentioned to me before that it's very mission driven for you and very values based. Like, you're not necessarily in this for the money, you're in it for the impact.
Well, definitely. Thanks. Yeah, I mean, we all like enough money to keep our families alive. My parents were missionaries, so I grew up without a lot of money. But the money wasn't the driver. It was... I think this is something that is good for our kids and grandkids, to not just take your bags of waste to the curb and have them go away in a garbage truck and have that bother go away, but take your bags...
And not even know where it ends up. And
not even know where it ends up.
Mm-hmm.
And, again, I'll be careful not to name the city, but there's a city in New York that has an incinerator, and not far from it, they have a super fund that's doing a cleanup. And because they have a very, very tall chimney on that incinerator that allows the plume to spread out, they don't quite get all the contaminants that their permit allows in the gases coming out of the chimney. And so they're cleaning up the Superfund by carefully and over a period of time adding contaminants into this incinerator as a way of getting rid of things, which is really just spreading it out over everybody. I mean, that's horrid, and that's happening. And it's not criminal because it's all legal, but it's wrong. So there's a difference between criminal and wrong, and it's wrong. And I really want to be part of something where us and a team around us have made a new way for people, and not just in North America, Europe, and so on, where we have money, but elsewhere in the world, where dumps are an issue. If they can get their collection together and get it on a truck and get it to a site, you could actually generate energy, you can generate fuels, and you make jobs from what was literally a poison for them. And that's really important.
I'll share. I know I normally don't do this, but when I was in my early 20s, I taught English in a rural city in China, and I had never left the country. Well, I had. I'd never been to China before, and it was very new to me. The first day that we were there, this bus drove us, out into the middle of nowhere, and the closer we got to where we were staying, the streets were lined with garbage for miles and miles and miles. And I was blown away. I'm like, what is this? This is so gross. It's like, that's what happens when you throw stuff away. These people just don't have as an effective of a system for hiding it, but like, it's there no matter where you are. So that was a really powerful lesson to me. Honestly, that may have been the first thing that got me thinking about climate issues, is just seeing that people live on top, like they almost have their tents stacked up on these garbage mountains, and it's
I agree. I grew up in Niger and later Benin, Côte d'Ivoire, and especially in Niger, Niger and Burkina Faso were the two rivals for who was going to be the poorest country in the world, and they've been tossing it back and forth for years. And through no fault of the people, just life is really hard. And garbage is part of it, and garbage makes dirty water and all the rest.
Yep,
so
all kinds of problems.
So, I got into this not looking for it, very glad to be in it. And I'm 66, could retire, don't need to work. I'm doing it because I want to make it happen. And I'd like to contribute to it in my lifetime and see it become a viable alternative.
Well, bless you. That's amazing. Okay, so I want to know, What are the current challenges? What's maybe holding you back from scaling this system further? What kinds of deals are you looking to make? I would like to hear about like the business scaling part of it.
Sure. So part of the challenge, there's a number of them. One is who's going to be first. Another one is how do you deliver? We deliver part of a solution, which is we convert waste to the syngas, and then nobody's using syngas in their homes. I
Yeah,
was
who
chair
uses it?
of what's that?
Who does use syngas?
Right. So I was chair of the Global Syngas Technology Council for 3 years, and I'm still a member of it. And basically, syngas is used all over the world. Syngas is a combination of carbon monoxide, hydrogen, and some minor gases, a little bit of methane, and it's typically made from petroleum products, but it's used to make ammonia, it's used to make hydrogen, it's used for all sorts of chemicals, making methanol. And how's it made? It can be made from like I said, from fossil fuels, can be made from coal, or it can be made from biomass, could be made from waste. And so the syngas itself is an intermediary product that doesn't have a market unless it's converted to something else or used in a boiler or used to run IC engines to make electricity. So one of the things we've done is partner with other people to take our syngas and provide the end solution, because you have people who have a waste issue and who have a need for energy or in some form. And taking the mystery out of it, we've taken the mystery out of the hard part, but the next hardest part is they're typically mature processes for going from syngas to something else. But the final client has to be able to understand and finance something that has a big block in it that's a mystery. So we're sort of the Intel inside the computer, but what we're saying is we want to be the motherboard. We want to be the Intel plus the next conversion process working together so that people can get lower priced, less experienced EPCs to do the regular work of bringing in the utilities and digging things and making buildings and running pipes, but not necessarily deep down in the weeds about understanding the core technology. So we've worked to package that. We've also worked to get away from custom delivery. So we've set up a supply chain, and the current tariff situation is disrupting it somewhat, but not so badly. We have suppliers in the U.S., we have suppliers in Thailand, in Canada, in Italy, and a few other places. So the product can get built, and we're without looking at a war. It can get built with geopolitical tensions and tariffs without too much issue. But the big thing is it gets delivered to the field, built in a shop, in multiple modules that get put together. And our business model there is very similar to that of a GE or a Siemens putting together gas turbines. They do the complex part. They ship it to the field as assembled units that on different trucks that come in big blocks and get put together in the field and ready to go. But the actual contractor doesn't have to know how to build and balance a turbine. He just has to know how to take part A and bolt it to part B and torque it in the right way and so on.
Kind of like prefabricated homes, but for
exactly, yeah. Megan. Yeah. And so that's been a lot of work. It took us almost 3 years to work through how do you package, modularize, and get things to go. And we believe it's important because it allows us to really tie down the cost. There's a current project, I won't name it, but people would know it if they look in the news. There's a project right now that's going bankrupt in Eastern Canada, not from technology, but it's in a similar field to what we're doing, and the bankruptcy is due to overruns in the project finances itself. And I think if a lot of this had been pre-modularized, pre-fit, and built in shops, they wouldn't be where they are. But when you throw a lot of equipment into the field and put contractors in and try to organize the chaos, the costs really go crazy. Yeah.
Mm-hmm. That makes sense. So, I mean, it sounds like you really have to solve so many of these problems, or at least impending solutions are happening. So, I mean, what does full scale look like for you guys?
So right now, full scale looks like we have a 200 ton a day unit. We demonstrated 135, so that's a scale up of just about 1.4 times, which is quite reasonable. If I'll quote Black and Veatch, they think that 3 times is a good scale up in this field. Because there's solids, liquids, and gases, you can scale up liquids and gases quite a bit more, but throw in the solids, it becomes harder. So we have 200 ton a day as a standard module. Excuse me, debottlenecking that to 300 tons a day. And we're offering it into projects already, but it won't, the first FID, if we were to take an FID on that, which is financial investment decision on that, we wouldn't take it before the end of 25. That's sort of where we are on the technology roadmap. And we intend to not get bigger than that until we have several years of commercial operation at 300. We have a roadmap that stretches out to 500 and 1,000, but we believe that there will be many more intermediate-sized projects, 200-300 ton a day, than there are 500,000 and more, just because of waste supplies and ability to finance, and so on.
So how are you getting these partnerships? I mean, I would assume it'd be pretty easy to be like, hey, we can take your unwanted waste. Like, how are you forming those connections?
That's a good question.
No, you're not the marketing guy, but
oh no, I've done a lot of this, walking through it. We have tried different things, and I think what we neglected and we learned, and we are doing it now. People want to be green, but they don't want it badly enough to pay for it. So you'll see people talk about hydrogen, and because there's no infrastructure for doing it, hydrogen as mobility is probably not going to happen in my lifetime. And I'm not being a prophet, I'm just looking at thermodynamics and economics. But hydrogen for decarbonization will. And the same kind of thing for SAF. So, people aren't going to triple the price of their plane ticket to be green. So the airline says, give me SAF at the same price you give me fossil fuels, and I'll buy it, but nobody can get there. So what we're looking at is we had looked at and talked to a number of developers. Developers have great ideas. A lot of them have a hard time raising money. We've talked to what we term the big shoulders people, the people who have the money, the petrochemical companies who have the money. They change direction with whatever the CEO decides to do in his next quarterly report. So it's very hard to get them to get, other than the fact that they want to be green, to actually get them to change who they are will take some time. And what we found is that the people who are the early adopters are not the people who are trying to be green. It's the people who have a problem with waste. They have another landfill cell to open up, or they have some problem with waste. And they say, why should I need to spend this money? Is what I'm doing the right thing to do? And so if you deal with people's pain, and you can solve their pain for the same amount of money and a better ROI as an alternative solution, I think that gets us to market faster on the early adopters. The later adopters will come in North America. There is a bit of a oligopoly around waste haulers. Municipalities own waste. They have to get rid of waste, so they contract with waste haulers who have the bankability and the means to take the waste and make it go away. And those waste haulers right now look at landfills that they have purchased and owned as being an asset that they want to make money with. We think in a few years, those waste haulers, when they have seen our process working for a period of time, and sort of the number is around five units for 5 years sort of thing, one of them is going to say, this would make me a bottomless landfill. I could still make money, and I'd still have all
I could keep taking
my stuff.
Yeah.
Right now, they're a bit of a competitor in the sense we had one who didn't put it in writing and didn't tell us, but told somebody else about us. If they get access to that waste, we're going to cut our price to zero just so they can't get the waste. So it's normal market pressures, and I think that by dealing with the people who have a need, who aren't big, it'll be fine. When the waste hauler finally gets to be the intermediary who keeps his contract but doesn't take it to a landfill, takes it to a landfill that might have 2 of our units on it, that will be fine with the cities as well. Then the mayor doesn't care about his election campaign because he hasn't really changed anything. He still has the same waste haulers.
Interesting. Yeah. Well, that, man, sounds like things, I mean, it's nice. There's just so much craziness going on across many sectors and government, but this is headed in a positive direction. It's funny. I personally just get so stressed out when I see garbage stresses me. And I'm just one person. So it's on a global scale, the enormity of this problem is just so crazy. So I just really was excited to talk to you today.
Thank you. Another little tidbit maybe for your listeners. People might not realize, but in North America, depending how you count the methane emissions, landfills are between 10 and 14% of all methane emissions in North America. And methane
didn't you tell me that was greater than the cattle methane?
Much greater. Cattle is about 8. Okay. And that's after we have piped landfills. But when you pipe a landfill to extract the landfill gas, you don't get all the methane. You get 60% on a good landfill. And we've had life cycle analyses done of this by independent parties. So there's a lot of gas that slips, and that amount of gas that slips is about half CO2 and half methane. And the methane on a 100-year cycle is 25 times the greenhouse gas potential of CO2. So if I'm not out raising money and saying we're going to change all the landfills in the world, but every little bit that you get rid of those anaerobic bacteria making the methane, and you turn that into a syngas whose end product will have CO2 in it, but that CO2 is mostly of biogenic origin, we can show negative CO2 emissions just compared to landfill as an alternative. And, it's really easy to meet the requirements, for example, for European and North American on low LCA. We meet that just by avoiding landfills. So that's not a reason to say pick our choice, but it's a reason to say, why would you go to a landfill? And an incinerator does the same thing, but an incinerator's CO2 goes up its stack, and it's almost impossible to do carbon capture on it because it's so diffuse, where we can send a better than 95% CO2 stream out the back end. with some amine capture. And so carbon capture becomes a very viable solution where there's the geology to do it.
That's so great. Thank you for sharing that point. That's super relevant. Well, I feel like I've learned a ton from you today, and thank you so much for continuing your work. Is there any last thing you wanted to add before we wrap it up?
I just want to say thank you, Megan. You're doing a good job. It takes more people like you to tell the world things as you see them. And, we don't have perfection. I think we are doing something that is very, very good, and that's why we keep doing it. And I really hope that our kids and grandkids profit from the fact that we have changed things. Jonas Salk got rid of polio, and Edison brought a light bulb, and we now have LEDs and not many Edison light bulbs, but it took an Edison. So we want to be sort of the Edison of the garbage world, if you want.
Ooh, that'd be a good episode title.
Yeah.
Okay. Well, thanks again. It's been a pleasure.
Thank you.
Thanks for tuning in to this episode of Green Disruptors. If you found Marc's mission and technology as fascinating as I did, be sure to share this episode and leave us a review. Every listen helps amplify the voices and solutions that are making a real difference in our world. For more insights and conversations at the intersection of climate, tech, and innovation, subscribe and join us next time. Until then, keep pushing for change.